Problem 4.2-1. The problem statement reads, determine the angle of twist at A relative to D in the solid shaft. The diameter of the shaft is 1 inch. The modulus of rigidity, or shear modulus, G is equal to 35 kSI. Here's the shaft from A to D. We're looking for the angle of twist at A relative to D, so we're going to be looking at the angle of twist over the entire shaft. We have various external torque loads applied, and the dimensions are given. We have everything we need to solve this problem. I'll begin this problem by identifying the positive direction for our torques. If we draw the x-axis as shown, and using the right-hand rule, the torques at A and D will be negative, and torques at B and C will be in the positive direction. I've now prepared my axis for drawing the internal torque diagram. Let's begin at point A and work towards point D. At point A, we see that we have a negative 300 foot-pound torque applied. So we will begin our diagram from dropping immediately at point A from 0 to minus 300 foot-pounds. And the torque remains constant at minus 300 foot-pounds from A to B. At B, we have a positive direction torque applied, 550 foot-pounds in magnitude, so we will jump in the positive direction on our chart from negative 300 up 550. That will put us at 250 foot-pounds. From B to C, the internal torque is constant at a positive 250 foot-pounds. At point C, we have a positive 200 foot-pound torque being applied, so we get another jump in our diagram from 250 up to 450 foot-pounds. Our internal torque stays at a positive 450 foot-pounds from C all the way to D. At point D, we see a negative torque of 450 foot-pounds being applied. That means we will jump down from positive 450 to 0. We close at 0. That suggests we drew this correctly. Next, I found a value for polar moment of inertia for the shaft. The shaft is solid. It has a diameter of 1 inch, so the radius is 0.5 inches to the 4th power times pi halves. It gives us a value of 0.0982 inches to the 4th power. This is the form of the equation for angle of twist that we'll be using in this problem because we have discrete torques being applied at intervals. Because J and G are constant in this problem, we can pull them out of the summation and sum our torques times our length. Using this equation, we are summing the angle of twist over the 3 distinct segments, A to B, B to C, and C to D. I've pulled J and G out of the equation. J is here. G is 35 times 10 to the 6th pounds per inch squared. And now I'm summing the torques times the lengths for the 3 sections. From A to B, the internal torque we see on the diagram is minus 300 foot-pounds. The length is 30 inches. In section B to C, the internal torque is 250 foot-pounds, and the length is 25 inches. And that 250 is positive. From C to D, we have an internal torque of positive 450 foot-pounds and a length of 30 inches. Notice I've included a multiplier of 12 here to convert the feet in foot-pounds to inches. I get for the answer 0.0375 radians. It's positive. That means the angle of twist at A is in the positive direction as described by the right-hand rule. And we're done.